Okay, so this is the video for 4.4. In your vocabulary grid, you have a definition for triangle rigidity, and it says that's the property where if you have the side lengths of a triangle, then there's only one triangle that can be made. So if I tell you that a triangle has side lengths 3, 4, and 5, there's only one way that triangle 3, 4, and 5 can fit together, meaning there's only one set of angles that can go with that set of triangles. So because of triangle rigidity, we get all these shortcuts from what we were doing in 4.3. So in 4.3, we had to prove that triangles were congruent by proving all three angles and all three sides from one triangle were congruent to all three angles and all three sides from the other triangle. So it was a lot of work. You had to prove 6 things in order to prove that triangles were congruent. Well, because of that triangle rigidity that says, if I have 3, 4, 5, then that's all it can be, that every 3, 4, 5 triangle has to be congruent to one another because that's the only angles that can be formed with that triangle. So because of that, we get our first shortcut congruence property, which is side, side, side. And we're going to have a bunch of these, and they're all named by what we use them with. So this one says, if the 3 sides are congruent, then I can go ahead and say the whole triangle is congruent. I don't even have to talk about the angles. So this cuts our work in half. We were going from 3 sides and 3 angles to now just 3 sides. So it's nice. It shortens our workload. Okay, so write a paragraph proof using side, side, side to prove triangle ABC is congruent to triangle DBC. So you don't have to do a paragraph proof. If you want to do 2 column, it's fine. A paragraph proof would say it is given that AB is congruent to BD and AC is congruent to CD by the reflexive property of congruence. BC is congruent to itself. We saw that one a lot in the last couple of days. Anytime a figure shares a side, it's going to be a reflexive property. Therefore, triangle ABC, again, make sure you write it in the right order, is congruent to triangle DBC by side, side, side. And that's a lot easier. I did it with 3 items, side, 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 rather than all 6. So it's a shortcut. Okay. Another vocabulary word from your grid is included angle. And it is the angle formed by 2 adjacent sides. So it is exactly what it says. It's the angle that's included in between the sides you're talking about. So if I'm talking about side AB and side BC, then angle B is the included angle. You can tell without even a picture what the included angle will be because it's the vertex that is shared by both sides. AB and BC, they share angle B, so that's obviously the included angle. Now it's easier if you have a picture, but it can be done without one. That brings us to the second congruence postulate, or theorem rather, which is side angle side. So it's just a different way to use those. It's just a different shortcut. And this one says, if 2 sides and the included angle from one triangle are congruent to 2 sides and the included angle in the other triangle, then I can go ahead and say the triangles are congruent. I don't have to know anything about the third side. We'll learn later on that there is a relationship with the angle and the side that it's across from. So that's where side angle side comes from. If this angle has to stay the same width about it, then the side across from it is going to be proportional. So if these 2 sides are congruent and the angle in the middle, then there's no choice for how long BC and how long DF have to be. They have to be the same. So that is side angle side. Notice the letters right there, side angle side. They're written in the exact order. So that is side, side, side. So now let's use it. Oh, one more thing. This is what I was just saying, but here it is on your notes again. That side angle side is written in that order because that's the way it goes in the picture. Side, then the angle is in the middle, and then the side is on the other side. So it has to be the included angle. Alright, so the diagram shows part of the support structure for a tower. Use side angle side to explain why triangle XYZ has to be congruent to triangle VZW. So again, we can just write a paragraph proof since we're already here and we need the practice. So it is given that XZ is congruent to ZV and WZ is congruent to ZY by the vertical angles theorem. Angle XZ, Y is congruent to angle WZV. Therefore, triangle XYZ is congruent to triangle VWZ. Now you can see that these proofs have been 3 steps rather than the 5, 6, 7 step. Now they could be longer and more difficult depending on the setup, but they're definitely going to be easier than proving all 6 pieces because you just have to get 3 of them, and usually some of them are given to you. Alright, example 3. Show that the triangles are congruent for the given variable. Now when this says show, you really have to show your work. It's not enough to just look at it and say, yeah, of course. So we're really going to show what's going on here. So we're going to say UT is equal to Y plus 3. So that would be 4 plus 3, which is 7. And 7 is the same as WX. Okay? Therefore, UT is equal to WX. Actually, from here, since we already showed they're equal, we can go straight to congruent from there. Okay, and then on the other side, ST is 2Y plus 3. So that would be 8 plus 3 is 11. And that is the same as WV. So ST is congruent to WV. Measure of angle T is 20y plus 12, which would be 20 times 4 plus 12, which is 92, which is the same as the measure of angle W. So if the measures are equal, then the angles are congruent. So we just plugged in what they gave me. I plugged in 4 here, here, and here, and it ended up being equal to here, here, and here. Therefore, I know I can say, oh, I did T is congruent to T. Therefore, I can say triangle STU is congruent to triangle VWX by side angle side. Okay, now make sure again with these congruent statements right here that you're making sure you copy them down exactly, because the order these are written in is the order in which you're saying the pieces are congruent. So even though these triangles are rotated, it's still the fact that ST is congruent to WV. So ST needs to be in the same place as WV, and on and on. Okay, one more. Alright, given that BC is parallel to AD and BC is also equal to AD, prove that ABD is congruent to triangle CBD. So as I look through here, I can see there's another given going on here later. So I know that I want to split up my givens. So I'm going to start with BC is parallel to AD. Now, as we discussed in class a couple days ago, if you're going from parallel and you're going to start talking about angles, you're probably looking at alternate interior, alternate exterior corresponding, and 9 times out of 10, when it is a parallelogram or a rectangle or some kind of figure like this, it's going to be alternate interior angles. Okay, that's one we're going to use a lot. Then we're going to use our other given. BC is congruent to AD. Reflexive property we also see a lot this chapter, and that is the shared side. So in this case, that would be BD is congruent to itself. And then lastly, we know we're going to copy that down exactly. We're not going to switch anything up. And why is it congruent? So in this case, you're going to go back to your picture. Oops, I didn't mark these. You're going to go back to your picture and look. Side, angle, side, side, angle, side. So side, angle, side. Okay, this is the end of 4.4.